a quick overview of how to plug into a download mission planner, how to set up the software side of things, and radio connection. Because I was a little bit lost in this. I've never gone down this path before. It was a bit of a learning experience, and it was a little bit lacking in information out there. So I just thought I'd share my little discovery path. So, one thing I have noticed,
welcome to HTX.
A lot of people, because this one, when I bought this off the guy, he used the quad to learn on, he bought it from somebody else, I don't know how many owners it's had. No one had ever calibrated the radio control. The computer inside needs to know the full travel, the extremity of the travel of everything. You go into system and you scroll through on the system menu, and anyway, you'll have your owner's manual, or there is so much information online, you'll soon be able to find a YouTube video on how to calibrate the relevant radio that you have. What we then need to do is calibrate the flight controller to the radio control unit. In the same way, the computer in here needs to learn the full travel of all the sticks and the pots. Now this computer needs to know the full stick travel of all the sticks and pots on your radio control unit. You are going to need the USB connector, so you can connect your USB lead direct to your flight controller inside. And make sure you use a good quality USB lead. It'll save you a lot of grief. You have the two UARTs, the serial ports. So this one is what I'm using for my DJI Air units. So the flight controller can pass through the OSD data into the Air unit that'll show up on the goggles. On the camera port there is 5 volt and 12 volt, and on the VTX from memory there's 12 volt. I've taken 5 volt and negative off there and run that through. It runs through here and is the power cable to power my second pan and tilt radio control receiver. Going by the manual, it actually says to take the 12 volt from here or here to power the air unit, but because they can draw quite a considerable amount of power, I didn't want to load this one up. And as I mentioned on the previous video, this lead that I made up plugs into the balance lead on the battery, on the flight battery. Not a recommended practice, and definitely not. I have a bit of a reputation for doing dodgy things, but the other option, of course, is to use a normal plug and run a second battery. So the other port here is the USB port. That's where this lead is going to plug in. There we go. I just like to make sure it's connected so I don't get any hiccups. You should now have this calibrated. You've set up a new model. Your usual channel 1, 2, 3, 4, and then channel 6 you'll allocate to a mode switch. So it seems a lot of people are just having the 3 modes on a 3-position switch. I went for the 6 modes, so I had to change the weight to 66%. Olivia on the Facebook page for the HeeWing, official HeeWing site, she actually said, because I could not get that to work, I could get, I think, 4 out of 6 modes, and I started playing with the curve and ended up, she suggested, no, just change the weight on channel 6 to 66%, and boom, I had all 6 flight modes. The other thing is I set my failsafe on Q return to home, and then set failsafe with everything powered up, of course, and I double checked it by having it in Qloiter, and then turned the radio off. And in the goggles it said return to home, QRTL. If it loses radio control link for whatever reason, battery goes flat, whatever, it will automatically, the receiver will trigger into Failsafe mode, and I've got that Failsafe set for Q return to home. So it's probably arguably one of the best outside of normal drones. For a fixed wing, it's a best case scenario. It will fly itself home and land itself right where it took off within a meter or two. So very clever stuff. My crossfire receiver, if I can get in a position where you can see it, that's my crossfire receiver, and the wiring goes straight down. Now it's in the way, goes straight down onto this plug here. It's a 4-pin plug. Now that connector that was provided was very, very loose, hot glued it in place. So also keep in mind the flight controller is pre-configured for both ELRS and Crossfire. I make no changes in Mission Planner in the software for the flight controller. Literally plug and play. If you click support, that's on their homepage. Then go down to instruction manuals. If you go to the bottom of this page, you'll see FX 405 VTOL flight controller. That will bring up this one here. So the first thing you're going to do is download Mission Planner. Obviously I already have. Mission Planner boots up. Once this is opened up, the first thing I would do is, well, first make sure you've got the correct COM port and change the baud rate. The baud rate, when I first installed Mission Planner, the baud rate was 9,600 or something like that. So the recommended baud rate is 115,200. I don't know if you can see that there. Then you plug in the USB. Radio control receiver is not powered through the autopilot. It's the flight controller. It's actually powered by the main battery off the power distribution board. So at the moment we're going to be limited as to what we can do, but we can get started. So first thing we'll do is connect, and we are connected. So when I move this up and down, you'll see artificial horizons moving, all the data's changing. Go into setup, accelerometer, calibration. What I do is I have this trusty little spirit level that I've had for years. It's just a nice little thing. It's worth taking the time to get this right. Put this down on the platform, both that way, longitudinally, as well as, so you can get this. So I had the back propped up and the side propped up to try and get it as level as possible. I start with the bottom one because it's perfectly level. Hit that, it'll reset itself and it'll tell you it's done. Then I'll do the next one because that's also level, so you don't need to touch it. You can calibrate level. The third one, the top one, is a little bit tricky. So when you click calibrate accelerometer, it will say successful. It'll take you through several steps. So then the next calibration will be on its left side. So you have to lie it on its side. The left side is if you're looking from the back of the plane. Then it'll ask you for the right-hand side, put it on the right-hand side. Then from memory, it'll ask you to stand it on its nose. So what I did was, and you've got plenty of time, there's no rush between each one because you have to actually click OK, and then it'll calibrate, and then it'll say successful, move on to the next part. I stood it up on its nose on these, leant it up against the coffee table. and using the spirit level, I was able to get it as perpendicular as possible to the floor. And then it's the tail, did the same thing again, had to stand it up on the tail. And then you need to roll it upside down. And again, I tried to get that. I did all of them with the spirit level. So it'd take me like 2 minutes between each one. Once you're finished on the back, then it'll say it's done. Then the whole thing is calibrated. So you don't need to do any more calibration for the accelerometer within the flight controller. So now I have the battery in. I'm just going to connect the battery power. So everything's still plugged in, USB lead and everything is still plugged in. I'm just going to power it up. Don't know if this applies for all radio control units, but the only channel I had to reverse, which was on the radio control, not on the controller, was elevator. So the pitch, which is the one on the left there. So when I pull back on the stick, it actually goes up on the screen. That's the pitch. That's the throttle. And you have roll at the top, which is ailerons, and you have rudder, which is the one at the bottom, or yaw when it's in vertical mode. And the interesting one is the 6 channel, the 6 position switch. So if I go to the maximum, you're going to see channel 6, radio 6. Flight modes. Now I'm lucky enough to have my 6 position switch happening, so this is what I have set up. Now you can change it. They're all the choices you've got, and that's basically it on that side of things. The configuration side, if you go to full parameter list, and then you can start looking at making some changes. Be really, really careful the changes that you make in here, particularly if you're not used to it. Any changes I made, I took a photo of the before and after. They do actually have default, but I don't know if that's HeeWing's default or if that's Ardu Pilot's default. So yeah, I take photos of all the changes so that I can revert back to it. If you go to, so for example, if we're going to check serial 1 protocol, here it says to type in 33. In my case though, to be able to get things working with my DJI goggles for the OSD, it was a little bit different. So if you go over to the right hand, you go full parameter list, search bar on the right hand side, and so I'll be typing in 01_ protocol. Back to mission planner over here, and so I could change that back to 33 if I wanted to. So you just click on it twice to get the highlight. I could change that to 33, as it says on the HeeWing's literature. Once you've put your change in there, you then hit write parameters, ask you to confirm, you hit OK, and that information will be changed on the flight controller. I'm going to go back to the full screen again, just delete all that, and it'll go back to the original screen. The other thing you can do is go to the Ardu Pilot Discord, and that's a rabbit hole to go diving into. So anyway, that's basically it. After you've written the parameters to it, disconnect up here. That's disconnected now. Unplug the USB, calibrated your radio. You've calibrated the radio control to the flight controller, and you've calibrated all the accelerometers, the 3 steps, and set up your OSD. So that is pretty much it. So quick assembly. Obviously the fuselage comes out of here. Take the rudder out, the horizontal stabilizer. Take the rudder out. That literally pops straight in there, and make sure it is clipped in. That's the release button right there. Then you take out, and this way everything is so fits so nicely in here. That's friction fit in there, so they don't go bouncing around. So you have 2 wing spars. You don't need to take the propellers off. There's recesses for all the propellers. So then we put same thing. There's a little button there. Click. So that's now into place. And well, that's it. Center of gravity. Center of gravity is something that is really, really important. So the first thing I'm going to show you is where the CG marks are. So this is more so for people who are new to radio control flight. Here are the markings under the wings that mark the CG points on the T2. You can see the diamond there beside the forward servo pocket. And there's another one right there, I'm pretty sure, right there. So you're going to balance the plane on those points. So when you're first checking your CG, being a VTOL, really important when you're doing your checks, you do it in fixed wing flight mode. So gently lower the motor pods into fixed wing horizontal flight. Pick a spot to put your battery, and I'll see if I can show you. Hopefully this will work. Another pair of hands would be great right now. So you can see motor pods in fixed flight position. You can see the diamond there. So I have one finger on each of the diamonds, and I'm going to try and balance that plane on those diamonds. Now at the moment I know I've got the battery far too far forward, so this is for the purpose of educational purposes. You can see it's tipping forward. So hopefully you can see that. I'm going to push it back. I'm pretty sure CG should be about there with this brick of a battery. When you're doing the CG, important you have everything in place as if you're going for a free flight, so for a fixed wing flight. So make sure the canopy's on, or the top of the fuselage hatches. If you're running another set of batteries for your video or whatever, make sure everything's in place as if you're going to be flying fixed wing right now. So then I'll find those marks again. And there you go, that's balanced. That's nicely balanced. Remember to have the motor pods in fixed wing fly-by-wire. Have the pods pulling the plane forward, and yeah, balance accordingly. So that's pretty much it for checking the center of gravity. Really important you get that right, really, really important. One thing I might mention is about the flaps, something I'd forgotten about earlier. There is an option with these to install flaps. So they're the flaps, they can be cut out. That servo pocket, the one closest to the flap, can be opened up and you can install the flaps if you like. Now, as a VTOL, it doesn't need flaps because it lands vertically. You don't need to wash off speed. The flight controller does all that itself. I've seen in some of the videos, watching the on-screen display, it goes into a mode called air braking, which is really interesting. I've never seen that before. So I guess that's where it washes off speed so I can go into vertical from fixed flight. I wasn't going to bother with the flaps, but I think I might do later on, because if I'm doing a flight around mountains or what have you, and I decide to come down the face of a mountain, it'd be nice to be able to keep the speed down. It's a very efficient airframe from what I have seen online. So I'm assuming it would gather some pace going into a vertical dive. So I might actually install the flaps at a later date, simply to use them as air brakes in fixed wing mode, just to slow the thing down so it doesn't get too fast. Just so it doesn't get too fast, because I don't want the pressure build up inside the fuselage and have the hatches pop off, because all my FPV gear is on top. I'm actually going to put some Velcro as a secondary fastening for the hatches on top, because my eyes are on top. I fly FPV. For whatever reason, the hatches decide to fly off, I'm blind. All I can do is go into Q return to launch and hope it comes home. And that's never a nice feeling, never a nice feeling. So my T2 didn't come with the paper instruction manual. So I just set my push rods in the top hole here and the top hole here. It appears to have enough control surface throw, so I'm going to leave it at that and see what happens with the maiden. I can't find anything on the actual throws, that is the actual travel, how far up and down past neutral the control surface should go. So we'll see when I maiden it. I'll see if I need more travel for more authority or less. Need to get these as level as possible, and you do that by screwing the clevis in or out as you need. So I have the plane powered up, make sure the trim's on all neutral, as long as it goes to center, and you get those as level as possible. And you'll do the same for the elevator. Have the plane set up level, and the elevator should be sitting level. An important factor is battery restraint. So HeeWing supplied this with the cross plate. I also have Velcro on the bottom here, and further back here I have Velcro on the rails as well, with a bit of Velcro underneath the battery. I'm not going to be doing any aerobatics with this, but the last thing you want is for this battery, it's a brick of a weight. If it slides forward, it could potentially end up disastrous. So particularly in fixed wing mode, or for that matter if it goes backwards, it's even worse. Make sure before you maiden you have adequate battery restraints in place. Okay, seeing as I've been rambling on about everything else, I'll show where you change the weight, at least in a Radiomaster Boxer, to give you an idea. The weight to be able to achieve 6 flight modes on the 6 position switch. And the other thing I'll show you is expo. The main screen on a Radiomaster Boxer. Go into model, page, across to inputs, and then you hold hold it down to get edit, and there's your expo. So I just go down to expo and click it once, and you can change it to whatever you like. So I typically start around 40 for aileron, 40% expo, and 30% on rudder, I think it was. Yeah, 30% rudder, 40% elevator. So what expo does is, instead of being really, really sensitive around center on the sticks, it means there's very little travel, and the amount of travel increases the further you go. So it kind of numbs the control around center, so it gives you a little bit more leeway. A lot of the scale guys prefer to fly with expo. I've been using expo ever since computer radios came out. You can really fly smoothly with expo. So I normally crank up the expo a little bit on maiden, so there's no surprises, because if this is really, really sensitive, super sensitive, especially when I don't know what the factory recommended control surface throws are, if it's super sensitive, you go into what's called pilot induced oscillation, and the plane, every tiny little moment, the plane twitches. So you end up in a case where you're constantly correcting yourself, and you have to consciously stop yourself from doing it and allow the plane to settle and try and get the plane down and desensitize it. So desensitize it, you can do one or two things. You either reduce the control throws on the ailerons and elevator, and or increase the expo to dumb it down around center on the sticks. So anyway, I normally start around 40%, 30 to 40%. This is a complete unknown to me. So that's basically how you set up your expo. To change the weight to achieve the 6 position switch, so you can have 6 flight modes, back to the main screen, model, page. Sorry, I'm trying to look past the phone while I'm recording. Back to inputs. Now, if you go down to channel 6, which is channel 6 is pre-configured in the flight controller for the mode switch, regardless whether you're using 3 position or 6 position. Again, hold it down, edit, and that's it there. 66% weight. That's the one you've got to change to be able to get all 6 modes on the 6 positions. Otherwise, I think these 2 were doubled up and these 2 were doubled up. It doesn't, the separation between each position didn't correlate to the flight controller, what's pre-configured. So Olivia on Facebook group was 100% correct, 66%, and it works perfectly. So if you do have the option for 6 position, I would strongly recommend it, only because it gives you more flexibility on your flight modes. When you are doing your testing, the first time you turn your radar control on, and you're going to turn this on for the first time, for the love of God, make sure those propellers are not on.
Telemetry recovered.
So at the moment, that far left out of the 6th position, that's in Qloiter. So that's in obviously vertical mode. To arm and disarm, so at the moment it's disarmed, you move the rudder across to the right and you hold it for 4 seconds. The plane will arm, and I'll show you what happens. You hold to the far right. Now she's ready to start flying. Hold far left for 4 seconds. Now it's disarmed. So now I can go full throttle, nothing happens. So standing behind the plane, so roll for the ailerons. So if I go right stick, you'll see the right hand aileron goes up. So that pushes the right hand wing down. Same for the left. Up elevator. So you're pulling the stick back, that's pitch. That's exactly what's going to happen. When I push down, the nose is going to go down. Pull back, the nose is going to go up. Then you have the rudder, and that's the channel I had to reverse in the radio before I started. And rudder's not going to work because it's not used in the vertical VTOL mode. So if I go to fly-by-wire A, you can see the motors. Motors have gone into fixed wing flight mode. Now I have rudder control. So when I push it to the left, being a full floating rudder, that's what's going to pull the plane around to the left in a flat turn and to the right. If I lift the back up, you'll see the elevator. I'm not sure if you can see that effectively. You can see as I'm pulling the plane up, so it's about level now, the plane. Pull it past level, it starts coming up higher, the elevator, because it wants to pull the nose up. As I drop it down, the elevator wants to go down because it wants to push the nose down because it knows it's going up and it should be level. And the same thing applies with the ailerons. I wish I had a better camera set up here. So if the plane banks to the right, left aileron's going to come up to bring it back level. And likewise, if the left wing goes down, the left aileron goes down to bring it back up level. And that's a correctly set up aircraft. Before you can launch this big bad boy, or small big bad boy, into the wild blue yonder, two things is ESC calibration and compass calibration. Electronic speed controllers. Typically when you buy a plug and play foamy, or pretty much any plane that's plug and play fixed wing, you're going to need to calibrate the speed controllers. And the reason for that is the speed controller needs to know the full travel of your throttle, which is quite simple. Turn your transmitter on, push full throttle, then you power up your plane. The speed controller will do its little tune or a beep or some sort of recognition, and then you pull the stick straight back down to 0, and it'll give more tunes, and it should boot up, should give the usual beeps for cell count. And I typically disconnect and then restart it again, reboot it before I fly. Quads are a little bit different. There are two different types of speed controllers. You have the typical analog type, which is PWM, just slots straight into the flight controller. Generally, you have to go through the same procedure. The other type is digital, something like D-Shot, which are speed controllers that digitally talk to the flight controller, supplying information such as RPM, the revolutions of the motors, so that the flight controller can control, particularly with a multi-rotor, which this is in vertical mode. It will know the revolution of all the motors and keep it perfectly in tune. So in that case, there is absolutely no calibration to be done. Now, I have had email contact with HeeWing, and it was confirmed that mine are analog. They are not digital, D-Shot or otherwise. So if I have to replace a speed controller, an ESC at any point in time in the future, I would have to go through the motions of calibrating the speed controllers. They also mentioned in the email that mine was tested at the factory, so it's already been calibrated. So I'm assuming that all the T2 VTOLs have been calibrated at the factory. There is an instructional video which is related to the T1, but the same should apply to this. Mine hovered perfectly, just a test hover in the lounge room, so I'm not going to play with something that I don't need to. It's been confirmed it's already been calibrated. I'm leaving mine alone. I'm assuming everybody else's would be the same. Just remember, if you do have to change out a speed controller at any point in time in the future, you will have to calibrate. So you've calibrated pretty much everything. Any stage of the game when you actually put it together and you're pairing it up, please remember to remove the propellers. You have double checked all the control throws, which is something you must really focus on. Earlier on in this video, you must focus on which direction the control surface is going. Then you've got to pick it up and physically move the plane around three-dimensionally, so you can see that the elevator is going in the correct direction. So when you tilt the nose down, the elevator should come up. So when it's flying, it should be trying to pull the nose back up. And with the rudder and the ailerons. So if everything is correct by the sticks and they are correct by holding it and making sure that the gyros are doing moving the surface in the correct direction, it should be safe to fly. As the HeeWing instructions clearly state, as soon as you pop it up off the ground for the first time, don't throw it straight into fly-by-wire. Take a minute or two to make sure that the plane is responding to all commands, stick commands, in the correct direction. So hovering, move the stick to the left, your right, forward and back. The right stick, assuming in mode 2, and pushing the right stick to the left, make sure it moves across to the left and to the right. Easiest done when you're standing behind it, so it's actually pointing away from you. And assuming that all that's correct, then you can bite the bullet, push it up into some decent sort of altitude, at least 3 mistakes high, as we say. So get it up around 300 or 400 feet at least. Put it into fly-by-wire mode. It'll automatically go into fly-by-wire if you have it on fly-by-wire mode A. I haven't flown this yet, but so I'm yet to do the testing on the different modes. Fly-by-wire A, as far as I know, is heavily controlled by the flight controller, so I'm assuming it'll be something like having an E-flight apprentice or something like that. I'm expecting the bank angle to be limited, pitching up and down to be limited, so it should be very, very easy to fly for a beginner. Now, the reason why I'm explaining this is because when you put it in a fly-by-wire mode, just gently move the sticks left and right, make sure that the plane is reacting to your commands correctly. So when you push the right stick to the left, make sure that it banks to the left. Push the stick to the right, banks to the right, push the stick away, goes nose down, pull the stick back, nose comes up, and the left stick, push it across to the left, and it should start trying to do a flat turn to the left, and vice versa. Push the left stick to the right and it should be trying to do a flat turn to the right. The compass calibration, this is something that I'll be doing at the field immediately prior to going up into the Wild Blue Yonder for the first time on its maiden flight. Compass calibration, going back to the early days of DJI, they had a huge headache of flyaways. Their drones, particularly when they came out with the, I can't remember what they were called, they weren't the Wukong, they were the budget entry, little flight controllers you could put on your homemade quads, and they had a huge number of flyaways. A large number of them were attributed to the lack of compass calibration. The magnetic compass is going to be affected by anything high tension electrically that's close to the GPS receiver, has the magnetic compass built in, so you've got to be careful that you don't place it too close to speed controllers or the cabling to and from speed controllers. I try and keep it separated from FPV video side of things as well, because there's a lot of RF being spewed out of that. So for example, my GPS is sitting here. I'm happy with it being there because this is a receiver and this is a receiver. Trying to get separation from my video transmitter here. There's not a lot of separation here. The guys with the T1s must have had a lot of big challenge trying to get some sort of separation. I didn't want to push this any further forward because I've got more work to do in this area here. So when I'm going to be doing my compass calibration, this is standard procedure, but it's also in the Ardu Pilot Discord. When you do your compass calibration, try and do it in an open field and try and stay away from overhead power lines, especially high tension power lines. Don't have your mobile phone in your pocket. Don't have anything magnetic anywhere near it. I even go so far as refraining from having magnets anywhere on the plane particularly anywhere near where the GPS receiver is mounted. I have read guys are putting magnets under the hatches to try and give additional securing so that they don't risk them popping off. Be mindful of how close you get those magnets, especially if you're using the high-powered magnets like the rare earth magnets. That magnetic field is going to wreak havoc on the magnetic compass. So yeah, open field, stay away from overhead cables and what have you, electrical cables. I'm not even doing it in the house here because we're surrounded by concrete walls and what have you. The GPS is picking up well, but magnetic compass, I'm just not going to risk it. The other thing that's mentioned on the Discord is to recalibrate the compass if you are flying more than 200 kilometers from the last known compass calibration. I would say if you're going to completely different sites all over the countryside, particularly if you're going from country to city or city to country, the amount of magnetic influence is going to have some sort of an effect. I particularly don't want mine flying off into the wild blue yonder. One of the telltale signs of the compass calibration falling out is what they call the fishbowl effect. So it'll start flying a little bit like this sort of thing. It could be either direction, could be going clockwise or anti-clockwise, but it's not sure where north and south is to orient itself. When I do my compass calibration, I'll be taking my laptop to the field and doing this before I fly. So I'm going to have quite a long USB lead because to do the compass calibration, it's got to be done through a mission planner, hence taking the laptop. So essentially you're going to be powering the plane up with the flight battery, plugging in the USB, going into mission planner, into onboard mag calibration, initiate it, click start, and then you're going to have to go through the motions of rolling it around and what have you. This is quite important in my opinion, but they've never done it. And that is about that. I'll put up a checklist either in this video or in the description on the video. Just a little checklist of everything you need to do prior to maiden. Good luck. I hope everybody else has just as much success as so many of the others I've seen out there with the T2 VTOL. And wish me luck on my flight. It'll be coming up very soon. So cheers, look after yourselves, blue skies. Ciao.